Now we're going to look at converting a mixed number to an improper fraction. First, we need to make sure that we're really confident understanding the relationship between the whole and the fraction that is equivalent to it. Here we have one whole, and I've represented it as 1 square. I then put an equally sized square underneath each of these incomplete fractions that only have their denominators. So what we want to know, first of all, is how many halves are equal to a whole. If we split it into half, how many pieces do we have? We have 2 pieces. 2 pieces make the whole. How many quarters make a whole? Here it is in quarters. 1, 2, 3, 4 quarters make a whole. Can you predict from this pattern how many eighths make a whole? One, 2, 3, 4, 5, 6, 7, 8. So we can say that when the numerator is the same as the denominator, we are equal to a whole. So 8 eighths make a whole, 4 quarters make a whole, 2 halves make a whole. We could also say, I'm not going to draw these, but we could say 3 thirds. How many 50ths? How many hundredths? How many 69ths? Well, if we split it into 50 equal pieces to make a whole, we must have 50 of them. If we split the whole into 100 equal pieces to have a whole, we must have 100 of them. And if we split the whole into 69 pieces to have a whole, we must have 69 of them. So here we have a mixed number. A mixed number is simply any wholes represented by the number written next to the fraction and any parts less than the whole represented as the fraction. An improper fraction is where all of the whole has been converted into the fraction. So we might call it a top-heavy fraction, but it's an improper fraction if the numerator is equal to or greater than the denominator. So for this to be a proper fraction, it would have to be 1. But if it was 2, or 3, or 4, or 5, or so on, it would be an improper fraction. So what we want to know is how many halves are in 1 1/2. So let's draw to have a look. So here is my whole. And from here we knew that 2 halves make a whole. So here we have 2 halves, and then we also have 1 half. So how many halves do we have altogether? 1, 2, 3. So 1 1/2 is equal to 3 halves. Now here we have 2 3 quarters, and I want to know how many quarters is that equal to? Well, in our 2 wholes, which I've drawn here, we have 2 lots of, well, 4 quarters make 1 whole, so we've got 2 lots of 4, which is 8. So that is 8 quarters. And if you look at our fraction here, you can see that 8 is 2 lots of 4 because we have 2 wholes. And here we have 3 quarters. How many quarters altogether? Well, 8, 9, 10, 11 quarters. So what did we do to find out how many quarters there were? Can we do it without drawing models to help us? Yes, we can. So 2. 2, we want to know how many quarters are in 2. Well, it's 2 lots of how many quarters are in a whole. How many quarters in a whole? Well, the denominator tells us 4. So that is 2 times 4. So it's 2 lots of the denominator. And then we have our numerator as the amount of quarters on top of that. So we have 2 lots of 4 plus 3 quarters. So that is our 11 quarters. So can we come up with a way of working this out without drawing? Yes, we can. We can go multiply the whole number by the denominator, and then all we did was we added on our numerator, because here we do it. We've got 2 lots of our denominator, because we've got 2 lots of 4, and then we added on this 3. So here we've got 2 times 4 plus 3. 2 times 4 plus 3. Let's do another example and see how this works without the model being drawn. What about 3 and 2 sevenths? How many sevenths is that equal to? What would I do first? Well, in one hole, I know that I have 7 sevenths. I have 3 holes, so that's 3 lots of 7, which is 21. But then I also have 2 here, so I've got 21 sevenths, and here I have 2 sevenths. So how many sevenths altogether? 23, because 21 add 2 is 23. So that is 23 sevenths. Let's do another one. 5 and 9 tenths. I want to know how many tenths. Well, in 5 holes, I must have 5 lots of 10 tenths, which is 50 tenths. Plus 9 tenths is 59 tenths. So what we did was we did times those together, then we added that on.